Hello everyone, welcome back. Today we're going to show the daily question on Leetcode that about find minimum time to reach the last room one. So I guess that your last room two. Mm, uh, this statement said that you're given a 2D array move time of size n x m, where move time ij represents the minimum time in seconds when you can start moving to that room. Mm, and uh, and you can only move to the adjacent room. Yes, the adjacent.
Adjacent.
Yeah, adjacent. I'm sorry. uh, two rooms are considered adjacent if they share a common wall. Uh, okay, for the let's see the first example. You see, it gives you two D array. Yeah, this. So that means if you are in this room, you can move to this or this. That's the four direction: east, west, north, south. Okay, now back to the example one. For example, this require you to you can only enter this room if the time now is greater or equal or the t is greater or equal to 4. So at the beginning t equal to 0, you are at this room. So if you want to move to this room, you need to wait. Yeah, wait to the time pass to 4. T 4, so you can go to this. And when you go from a room to another room, it's cost you exactly 1 second. Yeah, so at the moment you enter this room, that cost you five seconds. Then you go to this. That is the target. So that one. So the total is 4 plus 1 plus 1 is for you wait. Can you wait for 4 seconds? Then you go from the beginning room to this room and then go to the destination. So it's require you at least the minimum time is required is 6 seconds. Okay, and therefore the example 2 is require you 3. Yeah, this is a 2x3 metric. No, 2x3 array. Because it's 0 on, so you can go anywhere. So just go the path. The sorted path is require you 1 1 is 3. Okay. Yeah. Okay. Now we dive into the problem. Is how to find the minimum time to reach from the beginning room, that is the room 00, at time t equal to 0, to moving through the adjacent room to reach the target is the last room. This is n minus 1 and n minus 1 room, as n is the number of row and m is the number of column. Yeah. So look let's look at the constraint first. Is the 50. Yeah, so you can show it using an algorithm that's u and power 4. Yes, and power 4. But we can show it using an algorithm only to 2. So okay, now let's dive to the solution first. Let's dive into the solution first. So we can consider this metric as a graph. Yeah. For example, they give you this metric 1 2 3 4 5 6 1 2 0. For example, we have a 3 metric. Yes, or 3D arrays. So you can, instead of thinking this is a normal 2D array, let's think it as a graph. Yeah, This is what they give you. But let's think this is a graph. Why? Each, each, each room is a vertex, and we have in the room we can move to the four direction, right? And you can so this move can be represent by an edge. So we can convert this metric into a graph like this. Okay, from a node you can move to it is the unidirectional, because from A you can move to B and the B can also move to A, right? This okay. Now is we convert the matrix to the to a graph that has edge, S and vertex. So the task of you is to find the shortest path from the edge to the target, the short to the destination to our target. At 2t, while you can move through the edge. So let's think about the weight of this graph. So as you can see, for example, this graph. Okay, let's see this. Okay, let's use this graph. From this you can move to from the first cell you can move to the next room, but you need to wait 1 second. So it will cost you 1 minus 0, right, to wait, and 1 is the time you take you to move from a room to another room. So you can create this add of the weight is 2, right? I say this 0 because t equal to this elastic an edge E has a weight E the cell minus t are the current time plus 1 is the time take you take from go from a room to another room. So this graph might have a dynamic weight, not static like you usually do in some graph exercise. Okay, for example, this we have 0 start by t is 0, so we can move to this code 2, and at the moment you in this room t equal to 2, and you can move to this plus with the edge with the weight of 1, so you have 3. Now you are at t is 3, and for example you want to move to the below room, you need to wait to 5, right? 5, that means you need to wait 5 subtract 3 and plus 1 is the cost of moving, so it takes you 6, right? It's equal to 2 to 6, yeah, so t equal to 6 now, right? So if you want to move from this to this, it requires you 6 seconds of or if you want to move from t equal to this room, it may take you at the moment you are in the second room at t is 2, and it requires you 4. This will be 4 subtract 2 and plus 1 is the 2 to 3, and you will be at this room at the time of 5. Okay, so now we will to find the shortest path from A to B, you can use some algorithm like Ford-Bellman or this chart. I would like to use this chart, but this problem is only at n and m is not greater than 50. So there's only it's 50 is to about 2,500 vertices. So you can use if you use this chart, you can show it in O and the number of vertex. Okay, I'm sorry. What vertex and m multiple by log and v sorry v, this is the v vertex, and v let me write again, v plus e. V is the number of vertex, e is the number of edges, multiple by log n. If you use this chart with a priority queue, and if you use another solution like Fort-Bellman, it's okay. It's it's a v multiple e. It's okay. It's okay in this case. With number of e is about 4. Is about 4. It's v 4 multiple v. Okay. So I think this is the medium version. So I think the half version is less from 2, and the limit will be larger. So but I would like to use this chart because of it easy to implementation. You can use another shorted path finding like Fort-Bellman, but Floyd, but I choose this chart of curve is the optimization on with its low time complexity. Okay, now let's dive into the implementation. To do that chart, okay, let's write you need to create a private queue. First, let's create the state. We have the coordination. Let's see the coordination. I don't know. Coordination. No. Wait a minute. Sorry, I forgot. Coordinate. Why is the same as okay, coordinate. Coordinates. Coordinate. Oh, it's new for me. I read this word many times before, but I can't spell it. Coordinate. Yes. H and Y represent the coordinate. We use the weight as the weight, and weight is the path at the short path. What the sum of the path from the short is the 0 room to the current state. That's the current coordinate H and Y. And it's the state. Okay, and we need to put it in a priority queue to get the minimum. So we need to implement the operation. I don't know. I write true or wrong. I because it's been a while since the day I called C++. Okay, let's see. This is operator overloading. I forgot about the syntax, so forgive me. Yeah. Okay, it's correct. Okay, we compare it with another state. Order. This may return this way is less than the other way is considered smaller. Okay, now we create a particle with the state at heap. Call it heap, yes. Okay, dude, now we need to create an array to store the state. I will create at the limit is 50. Okay, and call it d, kd 50. Remember to use some extra space, not for any reason, just to guarantee that the cost will not encounter the scale that runtime error segment fault. Okay. We need to push the state 0 0 and the 0, the t equal to 0. This is t, okay. Y. Okay. First we need to maximize init the d array by okay, we assign to the maximum number, just the init step, and t00 equal to 2 as the at the beginning rooms is always t equal to 0. Pop it. No. Head, top, foot, no, h, e, and the day, okay, if the is not equal to the w, so we could continue. For we want to for from a cell. Okay, from a room you can go to for direction. This is minus 1 euro. This is plus 1 euro. This is 0. 0 plus 1, and this is 0 minus 1. We need to define the direction, the day. Okay, call this this distance. And create a d h a 0 0 1 e equal to 1 0 0. We for on the for direction, and the next room coordinates is plus e y plus t dy e. We need to check if it is inside. And so we will need to write a function that's the inside h e. We can write inside right here. For easy, I want to assign by time and n time 0 for to n. If it's not inside, that is when 0 and 0 v is not is less than n. So we continue. It's not the case because it's go outside. Like from this to go to this is outside. Okay, now we need to optimize if the let's get the curve t if curve t is plus from a weight, we need to calculate the weight. The weight is mass of we minus as I said before, we do a subtraction is about the next time is the move time uv minus current time and we plus 1 because we need a second to move from A to B, from two adjacent room. I forgot it. Let me adjacent, right? If the cost of move from HE to UVs is less than the most optimized for till now of U and V, then we update it and we update it to and push it to the heap U state and UV and this UV. Okay, the reason why I put if here is my iteration in an iteration they might have many states of UV. Yeah, so just ignore some not non-optimal weight. Okay, the answers is this of minus one. Check it out. What happened? Okay. Operator, sorry. It's the operator, not operation. I forgot about the syntax. Let's go. Sorry. Another mistake. A small mistake. Really? Surprised to reduce wait time? Nah, I don't have money. That's why I need to learn English. There is this number of costs, the required cost. Okay. Four. Okay. It's a classical and this is problem. I forgot to pop it out. Okay, I say this is a class. No, it's only you need to use diagram to solve this problem. So it can be easy solved by this problem can be easy solved by the diagram. Okay. Oh, I can't believe this solution is too slow. Why? Why is too slow? It's called you too much. Even I use the time complexity is small. So by the way, I got upset, but let's see whoa, I think it's the same solution. The same solution as me, but I don't know why they passed them. Okay, but we don't know. We submit it again to see. Oh, so it really slow. Yeah, I forgot. You get the mean, but the mean is like this. Okay, a mistake. Uh, then now you can see that if with the ground condition it's too current, but it's too slow because we only encountered the non-optimal solution. Okay, have a nice day.